So actually, class, itong tools ay related to statistics and then standardization methods. So class, let's begin with our intro to analytical chemistry. I hope classes will remember that analytical chem is closely connected to other fields of chemistry and the broader sciences. It is primarily concerned with the identification and determination of. Hello guys, here is our second crash course video. So our chapters are Introduction to Analytical Chem, Tools of Analytical Chem, and Standardization Methods. Mamich, part pa rin ba ng basics? Yes. Okay, kaya kailangan class, galingan natin ha sa mga basic topics natin. So for our intro, let us recall that Analytical Chem is closely connected to other fields of chemistry and also to the broader sciences. Ang laki-laki class ng role, very vital ang role na piniplay ng Analytical Chemistry in other sectors tulad ng medicine, engineering, pharmaceuticals, environmental science, at marami pang iba. Ang role class ng Analytical Chem is for the identification and quantification of substances in different samples. So i-appreciate natin na sa lahat ng analysis, sa lahat ng mga experiment, Analytical Chemistry plays a very, very essential role. Okay? So now class, kailangan nyo ng magandang understanding sa mga key terms natin, sa mga important terminologies natin. So homework nyo guys, reading homework niyo itong mga terms na to, kailangan familiar kayo dito. Let me give you some examples sa endemic activity tayo. So we have technique, a systematic approach or process used to perform analytical measurements, serving as the basis for gathering data. Example, spectroscopy, chromatography, gravimetry. Yun class ang mga analytical techniques natin. For method, a comprehensive and structured set of procedures designed for conducting a specific analysis with a defined technique. So under the spectroscopy, you have UVBIS, you have IR, NMR. Oh, diba? Ang dami nun. And then you have procedure, a sequence of written instructions detailing how to apply a particular method to analyze a given sample. So class, you can search the literature for your procedures, okay, under your method. And then protocol, a formal set of standardized guidelines often established by a governing body or agency for conducting and documenting the analysis of a sample. For example, class, gusto mo mag-analyze ng lead in water. So your procedure must be approved by EPA, Environmental Protection Agency. Okay? So kailangan may governing body or agency. Alright? So ayan class, meron tayong explain ng mga key terms now. Meron tayong papa-identify sa inyo. Okay ha? Kung talaga naunawaan yung mga terms guys, yung mga definitions nila, dapat kayo na sagutan itong mga items na to. Okay, look. Itong violet na spheres here in this example class, in this figure, ito yung compound or species. Okay, species of interest. Ano ito? Analyte. So this is something we analyze in our samples. Okay? So siguro yung blue yung sample, no? O yung green muna. Yung green muna guys, these are all the other components. So this is your matrix na present class in your sample. Diba? Ganda ng illustration na yan. Next. Okay, so we're getting something from our source here. Kaya yun. In the class, we get other portions pa na equal. Okay, same manner of getting or acquiring. Kung familiar ba sa term na to, these are your aliquots. So class from the book of Harris, coming from the lot, perform ka ng sampling and get your bulk sample. Then I hope you remember in lab bridging, perform ka ng sample preparation to obtain your homogeneous lab sample. And then now, you have your different aliquots. You divide your lab sample into different aliquots or portions. And class, these aliquots, you can measure them. Okay, pwede mo i-measure to. And of course, yung manner ng pag-measure mo will be, again, the same manner. So this becomes your replicate measurements. Okay, next. Very easy. Nasa part 1 class ng lesson natin sa anak mo. This is dilution, preparation class ng solutions. And then, di ba dapat familiar din kayo dito? Ito class ang mga standards or standard solutions for calibration. Makikita nyo class, yung gradient mo, pag-increase ng concentration. Now, let's have an example naman ng calibration curve. O, di ba? So, pinaplot natin here ang signal. So, ang signal here ay absorbance readings versus their concentration. Ayan. So guys, this is our last slide for Introduction to Analytical Chemistry. Now we move on to Tools of Analytical Chemistry. So very quick lang din to class, though may mga problems tayo which are not in your manual. Okay? So everybody focus kasi meron talagang statistics sa board exam. And naalala ko guys, ito ay usually nasa first part ng exam. Okay? So kung limot nyo na, yun yung formula dyan sa page 16 ng manual. Kung limot nyo na yan, you really have to focus here. Kasi medyo simple pa lang naman class. Simpleng mga equations lang naman to, like measures of central tendency, measures of data spread. Yung mga statistical formulas, yun, kailangan ninyong maalala. Okay? So everybody, let's start. So ito, central tendency muna, yung gitna ng mga data set natin. O class, fill in the blanks. So the blank, ano kaya to? Mean. Another term is average. Sum of all values divided by the total number of values. And for sure, remember, the median is the middle number when the data set is ordered, and the mode is the most frequent value in the data set. Okay, very, very easy class. So here, may example. So mean, you get the average. Ma'am, lahat ng values, yes. Inclusive class. Lahat ng values, no value left behind if you will get the mean or average. So for this data set, 5 is the mean. And then mode, ito class ang most frequently appearing. So 6, no? Sa dalawang best nag-appear. Median, pag in-arrange natin, 6 is the middle value. So ma'am, yung median, hindi siya affected ng lahat ng values. Hindi, gitna lang kasi siya. Okay, so class kaya, for sure, you remember in your thesis, you are getting the mean or average of your data set. Okay, now, kung may measures of central tendency yung gitna, here naman class, data spread, gano'ng kalawak ang data. So one measure is range, difference between the highest and lowest values in the data set. O ito height, as you can see, height is to ng family members, no? So yung height ng parents minus yung height ng children, yan ang range. So highest minus lowest. Another good example class, exams nyo. O for example, sa bridging FL exam, highest is 50. And then the lowest is 9. So you get the difference. That is the range. And the next, standard dev. A measure of how much individual data values deviate from the mean. So coming from the mean class, the formula is square root of the summation of all the deviation values squared over n-1. For sure, kasi remember, nare-report talaga natin ang standard deviation. Mean and standard deviation. Kasi ito class, deviation from the mean. O diba, mas valid itong pagkuha class ng standard dev. Okay? So practice tayo. Calculate the mean and the standard dev of the following results. So class, get your calculator. Punta kayo sa stat mode. Sa mga Canon users, na medyo similar din class sa Casio. So pupunta kayo class sa mode and then press stat. So that's 3. And then single digit na naman tayo, so press 1. Then mag-appear class ang matrix na nakalagay ay x, 1, 2, 3. So you will put in there your values. O ganyan ha. I hope napanood din ang class ang Math Bridging Part 1 at Math Bridging Part 2. So dapat alam natin how to use math, our tools, our calculator for the problems. So class yung gagawin nyo ng manual, ganito. I hope you remember pa din naman. So lista mo lahat ng measured values, xi, deviation from the mean, and then squared. So class, pwede nito i-pause to get the answer yourselves. The mean is equal to 15.80 grams. And then, magpaano po ninyo sa calcu. Sige. Lagyan natin sa calcio ha kung paano. Kasi canon to guys, sa canon user kayo dapat. Kung susundin ko sinasabi ko. So, enter natin ang values, 15.67, press equal sign, 15.69 equal sign, then 16.03 equal sign. And then press CA, press apps, then choose T5, S bar. Makikita nyo N, X bar, and then yung dalawang deviation. Doon tayo sa N-1 kasi ito ay standard deviation. So, press 4, equal sign, yun, 0.2. So, 0.2 gram class ang standard deviation. Okay? So, sana marunong kayo class mag-stat in your calculator. So, next, punta kayo class sa page 16 ng manual ninyo, A16. Sinummarize natin here ang mga equations, ang mga formulas na kailangan nyo. So, please tandaan ang class, absolute error, relative error. Lumalabas sa exam to. Nagpapagin ang formula niya. Q-test, Grubbs test, para sa pag-test ng outlier, which we will discuss shortly. Confidence interval of the mean, 1 sample t-test, 2 sample t-test. So, lahat ito class, very relevant ito sa nire-review natin. Okay? So, let's now move on to testing outliers. Dixon's Q-test is a very old test for outliers. You will calculate first your Q, so it's equal to the absolute value of suspect minus nearest over the range. So, class according to school, ganito ang logic ng pagkuha ng Q1 calculated Q. So your extreme value, let's say x6, kunin mo ang difference niya sa kanyang nearest value which is x5. So yun ang d distance. And then with gano'ng kalawak yung data, your range, highest minus lowest. O diba? Makes sense. It makes sense kung bakit ganito ang pag-calculate ng Q. Paano naman ang pag-conclude? If Q is less than critical value, retain. Ibig sabihin hindi siya outlier. If Q is greater than critical value, reject. Tanggalin mo na yung suspected value. It is now not part of your data. Ma'am, kailangan ba i-memorize namin to? Yes. And please guys, i-follow yung direction na binigay ko. Kasi hanggang t-test, ganito yung direction na ilalagay natin para consistent, para hindi kayo malito. Kasi baka mamaya iba-iba yung direction nyo eh. Magkaiba yung position ng calculated value dun sa critical ng galing sa table. Malilito kayo. Okay, so please follow nyo na ng class kung paano ko siya sinulat here sa slides natin. So kapag sinabi reject, tanggalin. Yes, tanggalin. So from 6 data points, meron ka na lang 5. So ano gagawin mo ma'am? Kung meron ka na lang 5, compute a new mean. And then you know move on to the next part of your analysis. Okay, kapag reject nga, tatanggalin. So here class is our Q table. So ma'am, yung supports, they can give us a Q table. Sa boards ko dati class, meron Q table. So ikaw mag-check ano yung number of observations, ano yung percent confidence sa sinabi sa problem, 90, 95, 99. Or kung titipid sila class sa space, they can just give you the critical value, the tabulated value. Okay? Now, meron din Grubbs test. As you can see, class, hindi ko inales yung conclusion. Ginawa ko lang siyang G. Class, ang Grubbs test. G is equal to suspect minus mean over standard deviation. So, class, according sa book ni Harris, ito ang mas valid na pag-check ng outliers. O, ano pong logic niya? Suspect, ito yung questionable value mo. I-measure mo siya, yung difference niya sa gitna, sa mean, and then divided by the standard deviation. O, di ba kanina sa Q-test, ang denominator ay range. So, here, standard deviation, difference from the mean or deviation from the mean. So, this test is now recommended by ISO and ASTM. So, pinapalitan na class ang Q-test. Kasi as you can see, no, mas nag-make sense yung kanyang formula. So, meron ng G-table. Ito na nga, G-table at 95% confidence. So, class practice tayo. So, here's our sample problem. Students dissolve snake from a galvanized nail and measure the mass lost by the nail to tell how much of the nail was zinc. The 12 results are given below. Is there an outlier in the data? So, class sa book ni Harris, ayan, ano pa, random pa yung data. Kailangan i-arrange yan. So, pag in-arrange yan, it looks like this. At ito test natin ay 7.8. Ma'am, how about 11.6, diba? Pareho naman yung extreme values. However, class, yung 11.6 kapag ginawa natin, retain to. Okay? Ang dali nyo makita or retain kasi, hindi ganun kalayo. Hindi siya ganun kalayo class from the other data. Pero 7.8, medyo questionable na agad siya. So, class, pause this video if you want to get the mean muna at saka ang standard deviation. Alright? So, kunwari, nakapag-pause tayo. 1A, okay, kayo talaga class ang hindi ko nakikita, pero yung unset sections kasi talagang ginawa nila to. Okay, hindi ko na pinapakita yung answer. So 1A, please do your best. Para naman may practice kayong mangyayari. May practice na nangyayari kayong ginagawa. Okay, while watching this asynchronous class first video. So, you will get your G, calculated G, 7.8 minus ang mean, 10.16, at ang standard def ay 1.11. So 2.13. Ano kaya ang critical value? You know, 2.285. So ma'am, less than. Yes, G is less than the critical value, retain. So wala tatanggalin. So wala tatanggalin. Your 12 data points are intact. You move on to the next part of your analysis. Ganun lang class kadali. Okay? So kapag retain. Kapag ma'am reject, ano mangyayari? Bawas ka na ng isa, 11 data points. And then class sa practice, pwede rin i-test yung kasunod, yung bagong extreme. And then when there's no outliers talaga, talagang check mo both your lowest and highest, talagang hindi sila outlier, you now move on to the next part of your analysis. Okay? So next naman class, finding the confidence interval. Class commonly, the true mean, the true value is not given. And to find it, you need to perform a lot of measurements. So most of the time, we just establish an interval or kung saan class, most probable nandito ang true value. So mu is your true value. We're establishing the confidence interval for the true mean or true value. It's equal to mean plus minus, kaya nga interval eh. So mean plus minus t. So ganito class sa t table times s, standard deviation, over square root of n, number of measurements. So class, clarify natin yung mga terms here. Confidence interval, range of values within which the true mean is expected to lie with a certain probability. So ma'am, example, 7.5 plus minus 0.5. O yun, interval yun, di ba? So sa range na yun, naglalay most probably ang true value. Confidence limits, ito naman guys yung boundaries. So mag-ibig sabihin sa example mo, from 7 to 8, yun yung boundaries niya. Yes. So boundaries, so hanggang class limits ng interval. Confidence interval at 95% confidence level, di ba? So probability that the true mean lies within the certain interval. Significance level is the opposite. Probability that the result is outside the confidence interval. See? Kailangan malaman yung class ng mga terms na to. So ito class ang T table. So of course, itong DF, degrees of freedom, ang formula ng class N-1. Alam niyo yan. For sure, lahat kayo nag-stack ng thesis ninyo, di ba? So we have 80%, 90, 95, 99, 99.9%. Ang most common na ginagamit sa mga problems ay 95. Okay, practice tayo. At time obtain the following data for the alcohol content of blood sample. Calculate the 95% confidence interval of the mean. 1A pause. Para kunin nyo ang mean. O kunwari nakapause na kayo. Mean is equal to 0.084. Standard def 0.005. From the T table, degrees of freedom is equal to 2 kasi class tatlo. Ang measurements natin 4.30. So here's the formula. Huwag nyo kalilimutan. So 0.084 plus TS over square root of N. 0.084 plus minus 0.012%. Madali na pala ma'am. Exactly. Madali lang siya guys. Okay? So do not ever forget finding the confidence interval for the true mean or the true value. Now class, kapag ito na i-arrange ninyo, in-isolate nyo itong T on one side, it now becomes one sample T test. Okay? So kung i-memorize sa class sa formula, lang sana, walang magbabago. Kasi pwede itong rearrange. Pag rearrange natin yan, transpose sa kabilang side, then you get your one sample t-test. Okay? So everybody, ang one sample t-test is used to decide if the population mean is equal to specific value or not. And commonly, the specific value class, ito yung standard, yung known, okay, yung known value. So example, ayan. So class, yung next naman, two sample t-test. Comparison to, for example, meron dalawang groups or dalawang labs. So they are working independently. And you want to check if the population mean for two different groups are equal or not. Okay? So you have group 1 or group A, group 2, group B. Iko-compare mo naman yung dalawang means nila. Two sample t-test yan. And then paired sample t-test to decide if the difference between paired measurements for a population is zero or not. Example class, pre-training, post-training, before, after. Kunwari sa exam, diagnostic exam, and then yung final exam. So kung meron bang difference, kung meron bang improvement. So class here, we will only use one sample t-test. Okay, here's ating crash course. Pero it's your job to also know two sample t-tests. So tingnan nyo, naka-isolate lang yung t-class on one side of the equation. Okay, let's practice. A new procedure for the rapid determination of percent sulfur in kerosene was tested on a sample known to contain 0.123% sulfur. Ma'am, bakit nakabold yan? Yan yung U, yan yung standard na value. The results were as follows. Do the data indicate that there is bias in the method at the 95% confidence level? Class, first, let us formulate our hypothesis. So your null hypothesis, walang difference. Your mean will just be equal to the true value or the standard. And alternatively, your alternative hypothesis does tell you na may difference yan, not equal to. Alright, so class game, mean is equal to 0.116, standard def 0.00316, at ito ang critical value, 3.18. Degrees of freedom 3 at 95% confidence. So ma'am, compute tayo ng T. So T is equal to 0.116 minus 0.123 over 0.032 over 2. Okay, so naka-round up mama. Yung standard def pwede naman. So class, this is 4.427 or 4.43. O, compare nyo nga sa 3.18, o diba? Mas malaki class ang calculated T. Ma'am, ibig sabihin, there's difference. Yes, there is difference. So, we reject our null hypothesis and we accept the alternative hypothesis. There is significant difference at the 95% confidence level. Thus, may bias in the method. Yung new method mo, okay, yung new procedure mo, there's something wrong with it. Kasi hindi siya nag-agree dito class sa known value. Alright? So, ganyan class sa paggamit ng one sample t-test. Alright? So, now we move on to errors in chemical analysis. Kanya yung mukha ni Kuya. Pwede magiging mukha ni class kapag nakadiscover kayo ng mga errors. So, there are three types: systematic, random, gross. O, class sa practice test 2 natin, may mga situations, merong mga cases, and kailangan marunong kayo na mag-determine kung anong type ng error. It's not just na ma-memorize ko naman, kaya ko na yan. Plus, may mga nakikita akong learning gaps in the onset section, marunong mag-define, marunong mag-describe, pero minsan nahihirapan i-apply. So, kailangan guys, mag-translate yan. Okay? From your definition, from the concept, going to application. So, for systematic approach, ito ay nag-affect ng accuracy. Yes, the results are reproducible. Yes, can be identified and quantified. And lalong yes, pwede mo itong gawa ng paraan. You can solve this through calibration, method adjustment, or equipment fixes. Kaya ang class ng systematic error, it's known as determinate error. You can always look for this. And take note class, ang systematic error may system, kaya siya consistent. Wow ha, nagkamali naman, pero consistent. Okay? Kaya siya nakaka-affect class ng accuracy. Random error affects precision. The results are not reproducible. Random nga. Okay, naka-fluctuate. Kaya ang tawag kasi dito, indeterminate. Okay, mahirap ma-determine. Lagi nandyan. Unpredictable pa. Paano gagawa ng paraan to? Actually, you cannot eliminate random errors. This type of errors are always present, but can be minimized if you increase your number of measurements. Okay? So, tinan yung tukos sa pipette. Dalawang type of error tukos sa pipette. If your pipette consistently delivers the wrong volume, baka mali. Okay, baka mali yung pipette na ginamit mo o may crack or something. Random error, variations. Kasi nga, ito ay pwedeng mag-fluctuate. Hindi mo pala alam. Nagkakaroon ka ng difference sa finger mo for sure sa pag-measure. Okay? Unknowingly, unaware ka. Or sa environmental factors na uncontrollable. Okay? And then gross error, it affects accuracy like systematic error. Class, ito, pansinin, noticeable, very noticeable ang gross error kasi ang results ay inconsistent, far from expected. Pero once nakita mo, uy, may gross error, can be corrected. Okay? Example, yung pala, maling instrument ginamit mo or maling reagent. O diba? Isang malaking pagkakamali. Yun class, ang gross error. O, let's see ha, kung kaya nyo mag-analyze ng mga scenarios kasi nga sa exams, ganito class, ang way nila on how to ask you the different types of errors. So before we proceed with our activity, let me give you this info from the book of school class wherein merong 3 sources ng systematic error. These are your method, instrumental, personal. So they lead to bias and measurement results. Method, they arise from non-ideal chemical or physical behavior of analytical systems. Blame it on the method. Diba? Instrumental, are caused by non-ideal instrument behavior, by faulty calibrations, or by use under inappropriate condition. So class, kung may nakita ka ng systematic error sa method, sa instrument, anong gagawin? Palitan, modify, optimize. O diba? Pwede mo naman kasi makonect because the errors that you will find are consistent. Okay, consistent na sobrang taas, sobrang baba, ganun. Okay, so you can blame your method, blame your instrument, but you can always fix it. O ma'am, paano naman yung personal? Siyempre, baka naman ikaw ang may error. Diba? So this results from the carelessness, inattention, or personal limitations of the experimenter. Okay? So ito class ang mga sources, systematic error, method, instrumental, and personal. Alright? Sige nga, mag-experiment tayo. Experiment tayo sa review natin, guys. Mga anong title yan? Plus, nag-isip ako ng maigi. The title of our activity, error 404 found. O, diba? Dapat tama kayo dito ha. Meron akong cases, and kayo class ang mag-identify ng types of error. Game, case 1. An analyst repeatedly weighs a sample and analytical balance. Each time, the reading varies slightly. So ito yung mga readings niya. Kung ano mga paiba-iba. Even though no changes are made to the sample or conditions, what is the most likely cause of this variation? O, class, tingnan niyo maigi. So the 3 values vary slightly. Kahit na wala naman siyang ginawa sa sample. So ano yun? Uncontrollable? Uncontrollable. So ano kaya ang error niya? Is it A, systematic error due to bias in the balance? Kung systematic error to class, dapat consistent. Okay, consistent. A, paiba-iba, nag-fluctuate. B, random error due to environmental fluctuations. Yan na ba yun, ma'am? Yes. Okay, yan ang answer class in case 1. O, dapat marunong na kayo ha. Next, case 2. A chemistry student measures the concentration of a solution using a spectrophotometer. The absorbance consistently produce values that are 0.05 units higher than expected across all concentrations. Upon investigation, it is discovered that the instrument was not zeroed before use. Di ka pa nag-auto zero eh. What type of error ito? So class, is it A, random error? No. Kasi nga, consistent yung kanyang readings na 0.05 units higher. B, systematic error ba? Yes. Yung class ha, madali lang. Itong case 2. Next, case 3. When performing a titration to determine the concentration of an acid, a student knocks over the burette stand partway through the experiment. Ayan, napaka-clumsy naman ng student na to. Solve the titan spills, and the student hastily tries to estimate how much was lost based on memory instead of repeating the experiment. Ha? Ano yun? Sa palagay ko mga 1.2 ml ang natapon ko. Wow, ang galing naman. What type of error has occurred? Plus ha, baka mamaya ginawa niyo to. Anong type of error ito? Ba, ano, may flow rate ka pang nalalaman? Wrong. Letter B, incorrect technique ka pa dyan ha. The correct answer kasi kita nyo sa malaking pagkakamali, di ba? Gross error due to clumsy behavior and poor lab practice. Kasi naman, dapat sa stable na lugar, yung hindi dadaanan ang burette stand. Okay? And lastly, ang ating mas challenging na case 4, in a field experiment measuring soil pH, a researcher drops and contaminates one probe reading. Hala! Occasionally reads the meter from an angle. Hala, di ba ma'am dapat eye level? O remember sa bridging eval exam, sinabi natin dapat eye level kayo class mag-read. Otherwise, magkakaroon ka ng parallax error. And later discovers that the pH probe was calibrated for a different temperature and than the field conditions. Which errors are present in this scenario? Hala, lahat na pwedeng mali. Nagawa ng class ng analyst here. Random and gross lang ba? No. Gross systematic lang ba? No, kulang. Yan. Ganyan karami ang error niya. Mag-assign natin. Yung systematic error niya class, nag-calibrate siya for different temperature. Ayan, systematic error yan. Check ko na lang ha. And then random, occasionally hindi siya nagpabasa at eye level. Random yun. Ano yung gross error niya? Yun, yung pagkakadrop, pagkakontaminate na class ng probe reading. See? Lahat na ng possible nagawa niya here. Okay, so class ganyan, tayo mag-analyze ng mga types of errors. So sana na-appreciate yung ating error 404 found activities. Alright. So now guys, move on to the last part of tools of analytical chemistry, ang figures of merit. So here in this figure, meron tayong limit of detection, limit of quantitation, and limit of linearity. So ang limit of linearity is the last concentration before mag-deviate. Okay, from the linear curve. Then we also have dynamic range, slope. The slope gives sensitivity. So class ng table na to ay reading homework ninyo. So nandito ang mga figures of merit, accuracy, precision, sensitivity. Ito yung slope. Ability of a method to detect small amounts of analyte. The limit of detection, the lowest concentration of analyte that can be detected. Limit of quantification or quantitation, the lowest concentration of analyte that can be quantified with accuracy and precision. Okay, lahat ito guys ha. Homework nyo yan. In Chemtech, very important ang figures of merit. Class kindly correct na lang itong percent recovery. So percent recovery, sa book ni Harris, ito kasi ang formula niya. So concentration of the spike sample minus the unspike sample over gano'ng karami ang inad. Mga yung spike, dapat alam niyo yan ha. So sa mga on-site section, nakapag-spiking daw sila during their experiments before. Class, tayo ay magkakaroon ng konting review ng curves. Pero class sa lab tech pa to. 1A, I hope you remember, when you enrolled, sinabi namin sa inyo, nasa enrollment form, that today, okay, I mean this year, starting this year, ay integrated na, incorporated na ang Chemtech review sa chemist. Kasi lumalabas na nito sa chemist. And for sure, many of you will also apply for the Chemtech board exams. Okay? So ito class, mga terms to under quality assurance, quality control na chapter. Pero kaming chapter on quality management. So kailangan ba ma'am, alam namin itong mga terms to? Yes. Kailangan alam nyo class yung definitions nila. So, ang to, overview. Okay, intro lang. Kasi you will have naman a lesson on this, on laboratory technology, part 2. Yung part 1 na bigay ko na ng lab bridging. So class, meron na tayong konting portion on spike samples. Kasi later, the standardization method, you will hear the word spike. Class, did you know? In Anachem, spike means intentionally adding a known amount of analyte to a sample for testing accuracy or recovery. For sure, alam niya ang spike. Ma'am, bakit meron isang picture? Kasi class, meron na tinatawag na drink spiking. It refers to adding a foreign substance, often without consent, kaya nga bad to someone's drink, typically for harmful or illegal reasons. So, diba? Meron palang similarity, yung spiking sa lab at spiking sa drinks. Pero class, kung kalilimutan, yung spiking sa lab, okay yun. Okay, legal yan. Alright? So, yan guys ang ating tools of analytical chemistry. Now, we move on to standardization. Ma'am, important pa sa exam, oo, sobrang important. Ito kasi class yung way natin to quantify. So, kapag meron kayo nakita questions on chrome, on electrochem, on spectro, na may mga standard, may sample, panigurado, standardization method yan. Maybe, iisipin nyo na kung instrumentation lesson to, ito po naman pala sa pag-quantify. O, diba? It's often disguised as instru topics or instru questions. Yun naman pala, standardization lang, which part dapat ng basic knowledge ninyo guys. Okay? So, let's look at the table, enumerating our common calibration methods. So, single versus multiple. Single mabilis, isa lang yung standard mo, pero lower ang accuracy. Multiple point, makaka-generate ka ng curve, more accurate. Class, ang in-out of con equations here ay galing sa book ni Harvey. Ma'am, pwede ba yung galing sa book ni Scoop tsaka Harris? Sanay nakasiya ko doon. Well, kindly check this out guys. Baka pwede nyo i-adopt to. Kasi simple. Yung kay Scoop at Harris, medyo complicated. Yung mga equations na yun, nagamit ko before, ng student pa ako. Kaso ang hirap na i-memorize. Okay, ito guys, madali. Ito lang kasi yung magiging basis ng lahat ng equation natin. So, signal is equal to K, sensitivity, times concentration CA. Yan yung basis ng lahat. From external to internal to standard addition. Okay? So, class, paki-adopt ha. Paki-open ng mind para i-adopt to. Kasi madali ito. Okay? Let's start with external standard method. So, these solutions are solutions with known concentrations of the analyte prepared separately from the sample being analyzed. Prepared separately or independently, kaya ang tawag natin external standards. So, tandaan nyo, pag gumagawa kayo nito, magkahiwalay syempre ang standards ninyo at ang sample. Kaya nga siya external. Pag isa lang class, ang ginamit ng standard, single point yun. Kapag marami, multiple point. So, gagawa ka ng calibration curve, mga advantage ba yan? Meron. So, our external standardization ay perfect kung marami ng samples. Practical, time saving for routine analysis. Kasi meron ka ng isang curve, kahit pa hundreds yung sample mo, mag-interpolate ka lang using your calibration curve. No, practice tayo guys, ang problem sa manual. A spectral method is used to determine the concentration of lead in blood. A standard solution with lead concentration of 1.75 ppb. O ayan, yun ang concentration standard. Has a signal, an absorbance of 0.474. Di ba class signal is equal to K times C? So meron ka ng signal, meron ka pang C. So K ba una i-compute? Yes. Kukunin yung class ang K ng standard. Na i-assume natin na pareho lang sa K here ng sample. So here sa sample, ang absorbance naman niya 0.361. So class ito 1K, 0.271. Ma'am, bakit mo i-assume na pareho sila ng sensitivity? Because that's the assumption and limitation na rin ng external standardization. Iisipin natin na pareho lang ng matrix, ang sample and standard. So in the second step, kukumpute nyo naman class ng C. So isolate C on one side of the equation and you divide your signal of sample over yung K na nakuha mo from the standard. So K is equal to, CA is equal to 1.33 parts per billion. Oh, ganun pala yun, ma'am. Yes. So yun class ang limitation, external standard. Now, if you have many standards, nakagenerate ka ng curve, meron kang linear equation, ito yung next problem sa manual na walang sagot, kaya makinig kayo. So the question is, what is the concentration of lead in a blood sample if the measured signal is 0.397? So ma'am, pag nag-plot po ba tayo, concentration po ba ay X? Of course. And then your signal is your Y. Itong 0.296 0.0, itong 0.003 y-intercept. Alright? So meron kang given na signal, hanapin mo lang concentration. So just suppose to one side of the equation, you have 1.33. Oh, madali lang pala. O, plus kasi here, may equation of the line na. So nag-ano na tayo, substitute. Meron bang error ang single? Meron. So single point leads to determinate error in an analytic reported concentration if it is incorrectly assumed na equal ang Ka ng sample mo at ng standard. So class, if you will prefer naman multiple point, make sure this will include at least 3 standards, though more are preferred. Alright? So isa pa, kailangan guys, yung standard solutions yun, they bracket yung expected range ng analytic concentration. Kailangan pasok because you will perform interpolation. Alright? So that's it guys for external standard. Now we move on to internal standard. Internal standard, tinawag siyang internal. Ito ay reference compound. Ito ay compound na chemically and physically similar. So mga kamukha niya, oo, similar sila, but distinct from it. Okay, magkaibang compound, magkamukha lang. It is added in a constant amount to all samples and standards containing the analyte. Ang purpose nito is that yung standardization method na to, it compensates for the errors that will be applicable for both standard and sample. Kaya kinukuha natin class ang ratio. Okay, so everybody, please follow me here sa ating derivation. So yan, pang-analyte yan. At ito naman pang internal standard. Then we get the ratio. Oh, I hope you can follow ha. So ganun pa rin, signal is equal to K times C. You have 2 equations for this, your analyte and your internal standard. Then get the ratio. O ma'am, di ba sabi nyo similar naman ang analyte sa internal standard? Yes, so we can let Ka over Kis big K. O, di ba? So may malaki kang big K. May malaking big K. Meron kang big K. So step 1, step 2, magpapareho lang sa external kanina, yes. So class, let's calculate K. Paano? O sa mga nalimutan na ang fractions nila, you isolate K on this side. So this one gets transposed to the other side. So ito class, dilipat natin. So magiging signal ratio, SI over SIS. Ang kaninong signal ratio yan? Sa internal standard. Okay? So signal ratio, so standard with respect to standard, times, pabalik rin natin ito, sa transpose natin, CIS over CA. O bawal malito ha. Ma'am, do you recommend na dapat marunong kami mag-derive? Yes. Kasi nga lahat galing lang sa S equal to K times C. Kaya kailangan marunong kayo mag-derive. Okay? So ang big K natin, signal ratio ng standard, times CIS. O sa mga nagtaka-transpose po kasi, kaya kailangan i-review nyo yung math bridging, diba? So nagtaka-transpose po kasi, so this is your internal standard concentration over analyte concentration. Step 2, isolate naman class ang CA. So CA is equal to, ito pa rin, yung signal ratio. Pero this time, pang sample na. And then, lipat naman class to sa kabilang side, transpose CIS over K. O, di ba? Madali lang. Kung tandaan nyo pa class, yung mga kailangan yung steps sa algebra, sa math. Okay? So hopefully guys, we're clear. Solve natin yung problem sa manual. So this method ay para kay lead ulit. Kung napansin nyo, very consistent sila ng ating analyte. But proper here is the internal standard. So ito naman yung unang ratio na sinasabi nyo kanina for the standard with respect to standard, yes. So, yun natin class, step 1, calculate K from standard. So K is equal to 2.37 times, ang concentration ng internal standard ay 2.25, ang lead naman 1.75. There you go, meron ka ng K. Next, calculate CA. So class, ang bagong ratio ay 1.8. I-multiply natin sa same concentration ng copper, the standard, over na calculate na K. Oh, madali lang pala mama. Yes, sabi ko nga sa mga on-site sections, mukha lang siyang intimidating at first. But if you know the base of our equation na S is equal to K times C, madali na lang siya guys. Alright, so sana nagawa natin yan. So class, we now have our third and last method, standard addition. Ibig sabihin, mag-add ng standard sa sample. Exactly. So class, kapag hindi match ang matrix, dapat mapag-match natin yan para maging valid na results. So you can perform matrix matching. Pero kung hindi mo kaya ang matrix matching, mahirap i-duplicate ang matrix na isang sample. For example, class complex wastewater sample. O alam niyo naman na maraming components ng wastewater sample. Mahirap i-duplicate ang matrix nun. So if you cannot perform matrix matching, pwede kang mag-standard addition. You add the standard to your sample. So class, ito ang mga variables. V for your volume, initial, final, kung may dilution na naganap, and then VS. Kahit gaano kalit ang init yung volume ng standard, ina-add natin yan. Ini-include din sa formula. Then signal ng spike, signal class ng sample. Okay? And then of course, ang matrix ay ginagawa natin pareho kasi nga ina-add mo yung standard sa sample. We're performing standardization na directly with the sample. So yung K ng standard at sample solution, pareho. Okay? So class, game, gawin natin yan. So take a look at our illustrations. Ma'am, galing kay Harvey po, no? Yes, galing kay Harvey. So class, at the left side, we have with dilution. On the right side naman, without dilution, mas simple yung drawing. So add tayo class ng sample, VI, then on one of your containers, add your standard. Okay? And then dilute, pareho na dilute kasi nga with dilution. Di ba class, dapat CA lang yung term. However, CA times volume ratio. Kasi nga may dilution. Yung paano po dito sa spike? Para sa spike, dalawa pinanggagalingan ng CA. Sample at syempre yung standard. So i-add natin yun together with the volume ratio. So ma'am, ready na ba? Ready na. Signal is equal to K at ito ang mga C terms nila. So for sample and for spike, di ba nga? Pareho ng matrix. So K is equal to K. So ma'am, pwede i-equate natin yung K equations nila. Yes. So K is equal to S sap over the CA term. And then K is equal to S spike over these two terms. So pwede nyo na i-equate yan. Ganon. And then last for without dilution, simple lang yung terms. Pero wag i-ignore. Don't ignore your volume of standard. Kaya gano'n kalit yan, known amount yan. So malaki class of effect. So same pa rin ang gagawin. And here, ang equations natin sa without and with dilution. So I hope clear sa inyo. Kaya sabi sa inyo madali eh. Basta alam niyo yung signal is equal to K times C. But here, you have to account for the volumes. Kailangan i-account yung volume class. Alright? So let's solve this problem. Ayan na. So ito ay may dilution. So ang volume ng sample, VI, 1 ml. And then dilute. So VF to 5 ml. Ang absorbance niya, 0.193. For your spike naman, alam mo paano itong 1 microliter? Convert na lang class to milliliter yan. So 1,000 ang difference, diba? So this becomes 0.001. Okay? So ayan, 0.001 microliter. Ginawa natin siya. 1 microliter, ginawa natin siya 0.001 milliliter. So ma'am, what do you recommend po to solve this? Shift solve. Or kung gusto niyo mag-cross multiply kayo, either way, makukuha ng class ang tamang sagot. So ako kaya ko i-cross multiply yan. Then combine like terms and then isolate CA on one side, boom, may answer na. So class, you can pause this video kasi ang answer nito 1.33 pa din. Okay, try ninyo ha. Try yourselves, try shift solve. Okay, para mas mabilis. So the students are claiming na mabilis kasi shift solve. Edi go. Just make sure you understand the concept, the principle of standard addition bago kayo mag-enter dyan ng mga values for shift solve. Okay? So this problem ng class ay without dilution as you can see. So 5 microliters, 0.005 ml yan. There. O, nasa manual din to pero walang sagot. Okay? So class, ano ma'am, same na yung answer? O, same na din yung answer, 1.33. Ang kailangan nyo 180 practice dito is how to perform the operation, how to perform shift solve if you want, or kung madali nga cross multiply, pero yung mas tinatamad eh. Okay? So ayan guys, it's all up to you. It's entirely up to you kung paano nyo gagawin ang math part nito. Ang mahalaga, napaliwanag na natin ang concept at ang principle. Now, let me give you some cases. Ang ating next mission, set the standard. Ma'am, bakit? Alam naman namin, class, kailangan nyo pa rin magkaroon ng practice, okay, ng mga scenario para maisip nyo, ano kaya magandang standardization method? Ano kaya ang most suitable? Okay, let's practice this before we end our crash course video. A chemist is analyzing caffeine and energy drinks using HPLC. A calibration curve is prepared by using known concentrations of pure caffeine dissolved in water. The curve is then used to determine caffeine concentration in the drink sample. That's obvious na, di ba? So meron siyang pinrepare ng mga concentration at gagawa siya ng calibration curve. O ano yun? External standard. O see, madali lang. Kailangan lang marunong tayo mag-analyze. Next case 2. A chemist is analyzing a complex wastewater sample with many unknown interfering substances. Hala, mahirap mong gayahin yung matrix. The sample matrix cannot be easily replicated. To improve accuracy, which method should the chemist use? Ano kaya ang dapat ng gamitin? Nabanggit na natin ito kanina. Standard addition method. You perform standardization class on the sample itself. Alright? And for the last one, case 3, during an experiment, the instrument response fluctuates slightly due to unstable source intensity. The analyst wants to compensate for these fluctuations by adding a compound similar to the analyte. I-add to both samples and standard. Alam na, ito class I, internal standard. So, getting the ratio, okay, of the signal of your analyte and standard will somehow compensate for these errors, for these fluctuations. Yay! O, class very useful itong Anakin 2. So, hindi lang to pang basic na lesson. Somehow, i-apply nyo sa class kapag may mga instrumental topics kayong nakita. Alright? So, everybody, ito ang ating niche list. Ito guys, ang nasa manual nyo on page 16, E16, your formulas for stat and formulas for standardization. So, class, galingan nyo ha. Galingan nyo in answering practice test 2. So, ayan, hinahighlight ko dito. Kaya hindi pwedeng makipag-argue, hindi pwedeng magsabi na, ma'am, sa problem solving na tuloy ako mahina, promise. Pero magkakamali rin sa concept, o, di ba? So, kailangan guys, i-strengthen niyo both ang inyong skills on answering conceptual and problem-solving questions. Kailangan both. Okay, kailangan both ay kaya ninyong sagutan. May lecture na tayo eh. Nabigyan ko ng class ng crash course. Nasa manual na rin ang core content. Yun ang Word version. Here naman, PowerPoint version. Aba, may coach ka pang nagdidictate ng gagawin mo. Diba? So class, please answer practice test 2. Section 1A. After nyo sagutan yan in your practice test booklet, make sure to also follow ang pagkasubmit ng forms ng ating practice test forms. Alright?